Hello students, hello viewers. Welcome to Senior College Mathematics. Topic of discussion is quadratic equations. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NABTEC, for JAM, or any other external or entrance examinations into high school, this topic, this lesson is for you. Lesson 8, the solution of linear and quadratic equations simultaneously. In this lesson, we want to learn how to solve a linear and quadratic equations at the same time, and you do that from the concept of simultaneous equation. Explanation: sometimes a linear equation and a quadratic equation needs to be solved simultaneously. An algebraic method of solution is shown with the examples below. So we use examples to explain this subtopic in details. So let us take some examples to continue the discussion. Determine the values of s and y which satisfy the following equations simultaneously. So let us determine that. Example 22, we have y equal to s squared plus s plus 1 and y equal to 4 minus s. So the first equation is quadratic because the highest power of s is 2 and the second is linear. So we take equation 1, y equal to s squared plus s plus 1 as equation 1. Then y equal to 4 minus s as equation 2. Because of the way the above pair of equations are arranged, they can be solved by equating them. Now, why am I saying that? Because the left hand side are equal, y and y. So by implication, the right hand side are also equal. So you equate them by having s squared plus s plus 1 equal to 4 minus s. Already we have quadratic equation, and if you follow what we've done so far, especially by the method of factorization and formula method, the right hand side needs to be 0 if you wish to apply any of those methods. So we have to move 4 and minus s to the left hand side to have 0 at the right hand side. So you have s squared plus s. If you move this minus s, you have plus s followed by plus 1. If you move plus 4, it becomes minus 4 equal to 0. So we add s and s, the 1 and minus 4, and that is s squared plus 2s minus 3 equal to 0. We can factorize. In doing that, we look for two factors of 3, the constant term whose sum is 2, the middle term in s, that should be minus 1 plus 3. If you write those two factors in terms of s, you have minus 1s plus 3s. Then the other terms equal to 0. The purpose is to get 4 terms and group them. So the first 2 terms, first group, last 2 terms, second group, equal to 0. From the first group, s is common. If you factor out s, note the term you factored out is used to divide each term in the bracket. So you have s minus 1 remaining. From the second group, 3 is common. I also have s minus 1 remaining equal to 0. Clearly, s minus 1 is common. When you take it out, you are left with s plus 3 that will form the other bracket equal to 0. So you equate each bracket to 0. So s plus 3 equal to 0, or s minus 1 equal to 0. You continue by transferring the constant term plus 3 minus 1 to the right hand side respectively. When you do that, you have s equal to minus 3 or 1 or 1. That is what you have. So this term should not be there. So s is equal to minus 3 or 1. But remember, you need to get y as well. You can use both equations, but the one that will make the work easy is the linear equation. So recall equation 2, where y is equal to 4 minus s. So when s is equal to 1, y becomes 4 minus 1 equal to 3. And when s is equal to minus 3, y becomes 4 minus 3, and that means 4 plus 3, and you have 7. Therefore, when s is equal to minus 3, y is equal to 7, and when s is equal to 1, y is equal to 3. So this is how you solve linear and quadratic equations simultaneously if one side is equal. So by implication, the other side is equal as well, and you proceed with the solution. Example 23, we have another system. 4s minus 3y equal to 17. 3s squared minus 3y squared plus s minus 4y equal to 73. Now in this example, we cannot use the first approach because none side is equal. So as for this, we have two equations. First equation is 4s minus 3y equal to 17, equation 1, and equation 2, 3s squared minus 3y squared plus s minus 4y equal to 73. So when we have it in this form, you start from the linear equation. For you to proceed, the only option here is to use the method of substitution of simultaneous equation. If you follow my teachings on that topic, that will be very clear. When you have linear and quadratic equation that you want to solve simultaneously by the method of substitution, you always start from the linear equation. So from equation 1, 4s minus 3y equal to 17. You make any of the variable the subject of the equation. So I want to make s, I have to transfer minus 3y to the right hand side. So you have 4s equal to 17 plus 3y. I have to divide through by 4 because I want s to stand alone. When you do that, you have s equal to 17 plus 3y all over 4. So we label this one equation 3. Now we have obtained equation 3 from equation 1. To continue, you substitute equation 3 into equation 2. Equation 1 produce 3, you put 3 into 2 and continue the solving. So substitute equation 3 into equation 2. This is equation 2. So where you see s, you replace it with equation 3. which is 17 plus 3y over 4. So we replace this s with what it stands for. Because s is squared in that place, you have to square everything. Then minus 3y squared. This is s again. You replace it with 17 plus 3y over 4, then minus 4y equal to 73. We need to simplify this term. Because of the square, you write 17 plus 3y over 4 twice and expand. When you expand, you have 3 bracket open 289 plus 102y plus 9y squared over 16. Over 16, you close the bracket. Every other terms followed. Now nothing is common to 3 and 16, so we have to open the bracket by multiplying each term in the numerator by 3. When you do that, 3 times 2, 8, 9, you have 8, 6, 7 plus 3 times 102y, you have 306y plus 3 times 9y, that is 9y squared, you have 27y squared all over 16, and every other terms followed. At this stage, it is wise to clear the fractions first. To clear the fractions, you have two denominators, 16 and 4. So the LCM is 16. So you multiply each term by 16. So if you multiply everything here by 16, you are left with the numerator, because 16 we cancel 16. Then followed by minus. If you multiply 3y squared by 16, you have 48y squared. If you multiply this term by 16, divide 16 by 4, you have 4. So 4 will multiply 17 and 3y. So you have 68 plus 12y. You multiply this term, that is 4 by 16. 4y by 16, you have 64y, and the right hand side by 16, and you have 1168. Next thing is to add like terms. Like terms here, for the power of 2. The power of 2 for the variable y, you start with this. When you add, you have minus 21y squared. The next like terms are 306y plus 12y minus 64y. When you add together, you have 254y. Then we take the constant terms, that is 6. Okay, we have 68 first, but let's start with 867 and 68. When you add together, you have 935 equal to 1168. Because we have the result at this point is quadratic, for us to solve with formula method, because we have big coefficient, the right hand side needs to be 0. So you have to transfer this term to the left hand side, it becomes negative. So if you add these two constants, you have minus 233 equal to 0, and the other terms follow. This coefficient of y squared needs to be positive, although it's not a must, but let's make it positive. To achieve that, you multiply through by minus 1. So you have 21y squared minus 1 times plus 254y, it becomes minus 254y. If you multiply the constant term by minus 1, it becomes plus 233 equal to 0. So this final result, we need to solve it, and because we have very large coefficient, let us go by the formula method. That will be very easy for us to handle. So the formula is y equal to minus b plus minus square root of b squared minus 4ac over 2a. By comparison, a is equal to 21, the coefficient of y squared. B is minus 254, coefficient of y, and C is 233, that is the constant term. So the next thing is to insert these values into the formula and proceed with further simplification. So you have the formula here with all the terms inserted, okay. You know b is minus 254, so there should be minus here. You know, in the formula you have minus b before minus 254, so there's minus, then minus b all squared. This is 4 times a times c, and this is 2 times a. So minus 254 becomes plus 254. If you square this value, you have 64,516. If you multiply these three numbers, you have 19,572. We go further by subtracting the numbers in the roots, and you have 44,944. If you take the square root, you have 212. So at this point, y is equal to 254 plus minus 212 over 42. That is from 2 times 21 now. You have 42, 42, and 42. Because of plus minus, we write the expression 2 times. So y is equal to 254 minus 212 over 42, or 254 plus 212 over 42. When you subtract, y is equal to 42 over 42, or 466 over 42. When you divide further, you have y equal to 1, or 233 over 21. So we have two roots for y. That also implies that s will be 2 roots. To solve for s, we've already made s stand alone in equation 3. So let's recall equation 3. That will help us to find s easily. Mind you, you can use any other equation, but since s is already standing alone in equation 3, it is better you use equation 3. So when y is equal to 1, you simply replace y with what it stands for in equation 3. That means s is equal to 17 plus 3 times 1, because y is 1 here, then all over 4. That implies 17 plus 3 over 4, and that is 20 over 4. When you divide, you have 5. Then when y is 233 over 21, s is equal to 17 plus 3 times y now. So this is the value of y, the second value. Then you divide by 4. From here, you can divide 21 by 3. When you do that, you have 7 remaining. So s is equal to 17 plus 2, 3, 3 over 7 over 7, then everything over 4. So this over 4, let us treat it as divide by 4, then all over 1, to enable us simplify the numerator easily. To do that, you can write 17 all over 1. So the LCM of 1 and 7 now is 7. If you divide 7 by 1 is 7, multiplied by 17, you have 119. You divide the LCM 7 by the denominator 7, you have 1. 1 times 2, 3, 3, you have 2, 3, 3. So when you add, you have 352 over 7 first. And you know, when dividing fraction, the division sign is always changed to multiplication, and the fraction at the right, 4 over 1, is inverted to 1 over 4. And when you reduce, you have 88 over 7. So therefore, when S is equal to 88 over 7, y is equal to 233 over 21. And when S is equal to 5, y is equal to 1. So these are the procedures involved when solving linear and quadratic equations simultaneously. Hello. End of lesson 8. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not saved, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work legally and genuinely, and the Lord will bless you. Goodbye.